Hello everyone. Our today topic is types of natural resources. We can see the country possessing a large proportions of world natural resources is considered under the developed country today. More natural resources, the country comes under the more developed, considered as a more developed country. So natural resources are as an indicator of socio-economic development. The larger the area under natural resources in the possession of the country, the greater the opportunity for the country to be socio-economically more progressive than the others. As the number of people increases, the total stock of renewable and non-renewable resources does not expand at the same rate, right? Because the resources are limited, natural resources are limited, though the populations are increasing, but the resources is not going to increase. It will remain as it is. So each individual shares of land, food, water, forest, and biodiversity declines because of the population increment. So next we can see the World Conservation Strategy 1980 was a landmark document prepared jointly by the International Union for Conservation of Nature, United Nations Environmental Programme, and the Worldwide Fund for Nature, with support from Food and Agriculture Organization and United Nations Educational Society, Scientific and Cultural Organizations. It was the first global framework to link, very important things, to link the conservation with human development. That means the development should also be there, but the conservation of nature must be there. So what we can say here, and is often regarded to be foundation of the modern concept of sustainable development. We can see this figure, what it represents. The figure is a graphical representation of the World Conservation Strategy concept, which highlighted the imbalance between human population growth and natural resources. You can see here the wheat and the tree. The tree and wheat are much larger compared to human figure. You can see the data of 1980, 2000, 2020. So we can see what this graph indicates, the diagram indicates. This indicates that natural resources, forests, crops, biodiversity were relatively abundant compared to the size and needs of the human population in the year 1980. You can see the strength of the number of populations were raised compared to the plants and the weeds. But as the time passes, it goes on decreasing. The natural resources goes on decreasing, whereas the strength of human beings go on increasing. So what the figure says that the human population growth and increasing demands put pressure on natural resources. If exploitation continues without conservation, each person will get a smaller share of the resources. Conservation and sustainable use of resources are essential for maintaining a balance between the human needs and environmental friendly. So what we can see here, the figure conveys increasing human dominance, and declining natural resources over time, 1980, 2000 to 2020. We can see here how the population increasing and the natural resources goes on decreasing, right? So for this, the World Conservation Strategies 1980 concept was developed. It was developed jointly by different organizations, as we have seen in the previous slide. Now we can see the definition of the natural resources. Natural resources are the naturally occurring components of the environment, such as air, water, soil, minerals, forests, wildlife, and fossil fuels that humans use to meet their needs. We can see these are the types of natural resources. Sun is the energy resources. Forest, rock, mineral resources, soil, air, oil, and water. So These are the types of natural resources. So we are going to begin the first natural resource, water. So water resources, what we can say about the water availability, about 97% of Earth's water supply is in the ocean, which is unfit for human consumption due to the high salt content. We can see out of 100%, that means the remaining 3%, out of 3%, 2.3% is locked in the polar ice caps. And balance 0.7% is available in groundwater and surface water in the rivers, lakes, or stream. So we can see how the amount of water is the smallest for us to use, right? So what we can say about the groundwater, uh, how actually where the groundwater is available inside the earth. What is aquifer? An aquifer is a permeable underground formation of rock or sediment that holds groundwater and allows it to flow freely through pores or cracks, right? So this is called as aquifer. So whenever we are going to dig a well, when we are going to pour the tube well, we get the water from the aquifer. So aquifers may be of two types. First one is called as unconfined aquifers, covered by permeable earth materials and recharged by water seeping down from the ground surface during rainfall and snowmelt. We can see the topography of the grounds. And the aquifer status also you can see the unconfined aquifer, right? Unconfined aquifer means directly it is in touch with the soil, directly in touch with the porous media. So this is the tubewell we can see. So unconfined aquifer. Below that, impervious layer is there. Again, below that, this layer is called a confined aquifer. And again, impermeable layer is there. So by the definition, we can say unconfined aquifers are covered by permeable earth materials. So in this, that means above the unconfined aquifers, the permeable materials are there through which the rainwater seeps through the ground surface and reach to the unconfined aquifer. Confined aquifers are sandwiched between the two impermeable layers. So these are the confined aquifers, which is sandwiched in between the two impermeable layers, the first top and the bottoms, and recharge only in those areas where the aquifer intersect the land surface. So how it is recharged? When it is exposed on the ground surface, so during rainy seasons, it get recharged and water accumulates inside this aquifer. As I told you, it is sandwiched in between the two impermeable layers. So whenever you are going to install a tube well, you can get the water with high pressures. Now we can see the surface water. By the name itself, we can see the water which is found on the surface of the earth. It's called as surface water. For example, streams, lakes, ponds, rivers, wetlands, or oceans. So this the figure indicates the surface water. So what are the importance of surface water? We can use for drinking water supply. We can use for agriculture, right? Irrigation depends largely upon the rivers, canals, and reservoirs. It can be surface water can be used for the industries, for manufacturing, cooling, or processing. In case of transportation, the surface water can be used. That means rivers, lakes, or sea act as a natural routes. Hydropower generations, dams, and or rivers provide electricity. Ecosystem support, wetlands, lakes, rivers, sustain biodiversity. So these are the importance of the surface water. Now we can see this is also an important topic, hydrologic cycle. How we can define hydrologic cycle, the path of water through our environment, known as hydrologic cycle. Hydrologic cycle. What are the various processes which takes place in hydrological cycle? We can see these are the processes which has also been shown in the diagram. The first one is the evaporations, water from oceans. See, evaporation takes place, as we know, from oceans, rivers, lakes, and soil changing into water vapors due to sun heat. Transpirations, plants release water vapor from their leaves. This is called a transpiration. So evaporation, transpirations, and together with the evaporation and transpiration is called as evapotranspirations. So what happens after evaporation and transpirations? The condensation takes place. That means water vaporizes, cools, and changes back into the tiny drops for the clouds. So then the next steps, once the cloud forms, precipitation takes place. Precipitation is nothing but it is the rainfall. When clouds become heavy, water falls back to the earth as rain, snow, or dust. So during precipitation, what is going to happen? The part of the water also infiltrate below the ground surface and which recharges the groundwater, right? So that is called as infiltrations. And the flowing water of the ground surface is called as runoff. So excess water flows over the land surface into the rivers, lakes, and oceans, and part of it infiltrate, which recharge the groundwater. And the last points you can see storage. So with the runoff itself, the water is stored in the lakes or the ocean. Finally, it moves to the ocean. So water is stored in oceans, glaciers, groundwater, lakes, and reservoirs before re-entering the cycle. So what I'm trying to say here, so this is a continuous process. Hydrologic cycle is a continuous process. Evaporation, transpirations, then cloud formations, precipitation takes place. So due to precipitation, some water infiltrates into the grounds, which recharges the groundwater, and the water which is flowing on the ground surface is called as runoff. Finally, it meets to the lake or the river or the ocean. So this is hydrologic cycle. Next, we can see what is the water quality. Water quality definitely it refers to the physical, chemical, and biological characteristics of water that determines its suitability for various uses or various purposes like drinking, agriculture, industry, or recreation. So depending upon the water quality, we can check its suitability for its reuse, for its use. It is essential to enforce water quality standards in the interest of public health. Polluted water generates waterborne diseases, which kills millions of people every year all over the world. So, water quality, whenever we talk water quality, how we can maintain the water quality. So, for that, we have to know about the drinking water standard. The drinking water standards are the values for which each parameter beyond which water is considered unfit for drinking. That means the quality of water is not good. So in the Indian standard IS 10500 2012, this is called a drinking water specifications. Has you see this is the this table indicates the drinking water standards for physical parameters. For example, color, odor, pH, taste, turbidity, total dissolved solids. So you can see here in this table, we see the characteristics and the two other things are there in the column, acceptable limits and the permissible limit in the absence of alternate sources. So two standards are given there in the column number 3 and 4. So what is the acceptable limit? This is the desirable limit standard, needed standard of a parameter in drinking water. Water having values within the acceptable limit is considered safe for good, safe and good for the health. For example, total dissolved solids, so 500 milligram per liter, which is acceptable limit, right? And the second column, next column, the column 4, we can see that the permissible limit in the absence of alternate source. This is relaxed upon upper limit that can be tolerated only if no alternative sources of drinking water is available in area. The next it says that it acknowledges that in many parts of our India or our country, especially rural or remote areas, water sources may naturally exceed acceptable limits. In some of the area of our country, instead of reject such water entirely, a maximum permissible limit is provided, beyond which, remember please, beyond which water is considered unsafe for human consumption, even in emergencies. For example, as I told you, the acceptable limit for the total dissolved solid is 500 milligram per liter. But in case of absence of alternate sources, we can go up to 2000 milligram per liter, right? But beyond that, it is not acceptable. That's why it is written there. Even in emergencies also, beyond this limit is not allowed. Now we can see the next things. It is the general parameters. In the previous slides, we have seen the physical parameters. So in case of general parameters, here we can see that, for example, the fluoride. The fluoride 1 milligram per milligram per liter is the acceptable limit, whereas the permissible limit in case of absence of alternate sources is 1.5 milligram per liter. Likewise, there's some more general parameters. We can see in case of nitrate, 45 milligram per liter is the acceptable limit. But where the alternate source is not available, in this no relaxation has been given, right? That means 45 is the water quality has to meet the 45 milligram per liter. Whereas we can see in the case of zinc, 5 milligram per liter is the acceptable limit, but permissible limit, it can go up to 15 milligram per liter in case of absence of alternate sources. Next, we can see some of the toxic substances. These are the parameters, acceptable limits and permissible. What one thing we can see here, one of the important parameters, the total arsenic. Arsenic limit is 0.01 milligram per liter is the acceptable limit, but maximum limit is 0.05 milligram per liter in case of absence of alternate sources. But in most of the cases, you can see no relaxation has been given, right? It has to be met up to this limit only. Next, we can see about the radioactive substances. You can see here alpha emitters, becquerels per liter. This is the unit of this parameters. Alpha emitters, 0.1 milligram, 0.1 becquerel per liter. Beta emitters, becquerel per liter, 1.0. But in this case, no relaxation has been given.